Hey Year 12, welcome back to our second MM6 video. Right, some more work here on latitude and longitude, but we're going to look at some great circle distances today. So, what is a great circle? A great circle is a circle on the Earth's surface that has a centre at the centre of the Earth. Okay, think on that for a moment. The centre of the circle is the same as the very centre of the sphere. So, the equator is a great circle. The centre of the equator is at the centre of the Earth. All of our meridians of longitude are great circles. They pass through the North and the South Pole. Right, so halfway between the North and the South Pole is the centre of the Earth. If I think about something like the 30th north, the 30 degrees north parallel of latitude, right, think about where that is. It's parallel to the equator. The centre of that circle is above the centre of the Earth, right? It's on the axis through the centre of the Earth, right? But it's not at the very centre. It's on the axis, but not in the centre. It's above the equatorial plane. So, great circles are very nearly 40,000 kilometres long, very nearly. We are not going to use that approximation for the length of a great circle. We are going to use the radius of the Earth at 6,400 kilometres. Remember, circumference, twinkle twinkle little star, circumference equals 2 pi r. 2 times pi times 6,400 is pretty close to 40,000 kilometres. Now, it is only an approximation. The world isn't perfectly round, but your formula sheet gives you the 6,400, so that's what we're going to use for our calculations. Remember that formula for a circumference, 2 pi r, and arc length is theta over 360 times 2 pi r. Right, those are things we're going to need for today's lesson. So, we've got the coordinates of these 2 points, A and B. I want to know the angular distance. Now, don't get put off by distance. It's the angle that I'm interested in. Now, notice here, 130 east, 130 east, they have the same longitude. That means that they are on the same great circle. That's a good thing. We could actually work out the distance between these points, not just the angular distance. We're going to work out the angular distance, what I asked for. So 20 degrees south, 15 north. They are different, so we add them. 20 plus 15 equals 35 degrees of latitude. Oops, it's not how you spell latitude. Latitude. Difference. Okay, nice and easy. Next up, great circle distances. Right? Theta over 360 times 2 pi r, and r for us is always going to be 6,400 kilometres. It's on the formula sheet. Now, here we are, P and Q. I have these coordinates. Notice again, 30 degrees west, 30 degrees west. We are only going to work out great circle distances, and we are only going to deal with great circles that are either the equator or a meridian of longitude. So, to work these things out, you can anticipate that every question you will either have the same longitude or they will both be 0 degrees north. Right, they'll both be on the equator. One way or the other, you've got to do those things. There is a very rare exception to this. We'll talk about that in class. Now, I want to calculate the distance between these 2 points to the nearest kilometre. Be careful there, nearest kilometre. Now, the question tells us, not 640, 6,400 kilometres. You may or may not get that in HSC question because it's on the formula sheet. So, first of all, same longitude. Same longitude. That's a good thing. Now we need to work out the difference in latitude equals, I've got a north and a north, so I can subtract. 39 minus 27 equals 12 degrees difference. So our distance equals, or arc length actually, I think we typically use an L for arc length. Arc length equals theta over 360, that's 12 over 360, times 2 times pi times our radius of 6,400. Now sometimes when I'm working these out, I don't use the 2 and the 6,400. I just keep those together and say it's 12,800, right? So that will be theta over 360 times pi times 12,800, because it's always the 2 and it's always 6,400. Okay, anyway, that's the way the formula is given to you, is theta on 360 times 2 pi r. That's how we work it out. Now, if I punch those into my calculator, I think I know that the answer there is about 1,340 kilometres to the nearest kilometre. Right, it's 0.4 or something, I think. Something to keep in mind, if you ever get an answer there that is more than 20,000 kilometres, you've made a mistake, because nothing is more than 20,000 kilometres away. Right, a great circle is 40,000 kilometres. Right, you could go either way around that circle. If you've gone more than 20,000 kilometres, it would have been shorter to go the other way. Next question, example 4 here. I've got 2 points on the Earth's surface. 32 north, 120 east, 45 south, 120 east. Okay, same longitude. Not same longitude. That means we can work that out. Right? They're not on the equator, but they have the same longitude. Now, I need to calculate the distance. Right? Remember, these things we've got to do. Calculate the distance to the nearest 100 kilometres. Righto. So we need to work out theta for our formula. Now I've got north and south. They're different, so we add them. 32 plus 45 equals 77 degrees in angular difference. Now we put that into our formula, keeping in mind the other things are always fixed. So our arc length or distance equals 77 on 360 times 2 times pi times 6,400. Okay, type that into your calculator. To the nearest 100 kilometres, I think it's pretty close to 8,600 kilometres. All good? Rightio. One more example here, I think. Actually, have a look at this example here. If you would like to try to work that out, you are welcome to have a go, right? What you'd need to do there is have a look at this and find a right angle triangle to work out what that short radius is. Right, you're going to get a radius that's not 6,400 kilometres. Yeah, not 6,400 kilometres, and you can work that out. It is not in the syllabus. It's not something you have to do. I'm going to put a line through it. If you are looking for a challenge, you want something else to do, that's great. You can try to work that out, but it's not on the syllabus. You don't need to answer that sort of a question. That's going to do us for the video. Hope you enjoy that. So come back to here, a recap. Great circle distances are either going to have the same longitude or they're on the equator. And we calculate it as theta over 360. That's an angular difference over 360 degrees times 2 times pi times our radius of 6,400 kilometres. Right? Common questions? Practice them. Let us know.